Hey everybody, it's Mr. Oaks. So today's video is about comparing proportional relationships. Now a proportional relationship is one where we have what's called a constant ratio, where the relationship between the change in y, the change in the up-down on a graph, and the change in the x, that's the left-right on a graph, is constant. That when we divide the y value by the x value, we get the same thing every time we go to a new point. There's a few ways that we can represent proportional relationships. We can represent it as a table, we can represent it as a graph, we can represent them through an equation, or as basically a written out problem. You usually think of it as a word problem. When we compare proportional relationships, what we'll usually do is compare relationships that are represented in different ways. So graph to a table, graph to an equation, table to an equation, and so on and so on. So we're going to look at three different ways, three different comparisons, and look and see how we're going to do this. In order for us to actually compare different proportional relationships that are represented in different ways, we need to find what's called the unit rate. And basically what that is if I was going at 1 unit, so the price per unit, the distance per hour, things like that, we're talking about in 1. So you would think of a unit rate that you hear a lot is miles per hour. So when a car is going 60 miles per hour, what we're looking at is a car going that in 1 hour it's going to go 60 miles. And we can figure that out by doing a couple different computations based off of, well, how far did the car go over what amount of time? And that's what you would do. You would figure out, well, then per hour it's going this far. And that's what miles per hour means. So we're going to look at this first one here. And then we're going to actually... I'm falling off the screen. So we have two people, Tom and Chris, and they were both bicycling. And what we want to figure out is who cycled faster, who went faster on their bike. So what we have here is this table represents Tom. And we see that the top is the number of hours Tom was riding, and the bottom is his distance in miles. And that's another thing. We want to make sure that when we compare, we're comparing the same units of measurement. So we need to make sure that if one person is doing hours, the other person's hours. If one person is miles, the other person is miles. If they're different units, then we got a couple extra steps to do. So I look here and I see that in 2 hours, Tom is going 20 miles. In 3 hours, it's going 30 miles. 4 hours, 40 miles. 5 hours, 50 miles. So what we're going to find is what's known as the constant of proportionality. And we find that by dividing y over x, the y value over the x value. We can also think of this as the dependent variable over the independent variable. Hours, time, is not dependent on anything, so that is our independent variable, because no matter what you do, time marches on. Whereas distance, that's a dependent variable, because the distance you go depends on how long are you going. So what I'm going to do is I'm just going to choose something easy, the 20 and the 2. So the 20, the distance, is our independent variable. So I'm going to do 20, and we're going to divide it by our independent variable, 2. And what we get is that Tom is going 10 miles per hour. When we have a graph, what we need to do is, again, we're going to look at the change in y over the change in x. Now, I can tell that this is a proportional graph for two reasons. One, our line is starting at 0, 0. It's starting at the origin. All proportional relationships start at 0, 0. So, whenever we have a graph, it's going to be starting here. The second reason I know that this is a proportional relationship is because I have a straight line. All right? Proportional relationships, the graph, I have a straight line that goes through the origin. That's always a proportional relationship. So what I'm going to do is I'm going to find a point on here. First, I'm going to look at the y value. So I'm going to look at the change in y, which is going to go at 18. All right. And then I'm going to look at the change in my x. Actually, I'm going to use a different color here. Use green. And that same point is at 2. So that's my change in x. And when I do that, 18 divided by 2, that's a 9 miles per hour. So Chris is going at 9 miles per hour. Tom is cycling at 10 miles per hour. So Tom cycled faster. Tom cycled faster. He cycled 1 mile per hour faster than Chris. So that's what we do. And that's usually what you're going to do when you compare is it's going to either be who was faster, who was slower, what cost more, what cost less, so on and so forth. So now we have here, whose pizza cost more? We got Tony's Pizzeria, which is represented by a graph, and we have Gio's Pizzeria, which is represented by an equation. So again, the graph, I see again, it is proportional because it's starting at 0 and it's a straight line. So what I want to do is I want to find the change in y over the change in x. So again, I'm going to look. I see that here we have the amount of money made. Amount of money is dependent on the number of pizzas sold. So the amount of money is our y value. So I look, again, I'm going to go here. That's 24. So it's $24 for 2 pizzas. Okay. So 24 divided by 2 is $12 per pizza. I have a new camera, so if this looks a little weird, that's why. The other one died. Okay, so when we have an equation, what we're going to have is the general form of an equation that's proportional is y equals kx, where k represents what's called the constant of proportionality. It's the same as the rate of change, especially if you hear the slope. This is basically the slope of a proportional relationship. And what I'm really looking for here is that constant. That constant is going to tell me, well, how much does each pizza cost? So as long as I line that up, all my work is done. K equals $15 per pizza. So I look at this and I say, okay, well, whose pizza cost more? Tony's Pizzeria or Gio's Pizzeria? Tony's Pizzeria costs $12 per pizza, but Gio's Pizza costs $15 per pizza. So Gio's Pizza cost more. So if I'm on a budget, I'm probably going to go to Tony's Pizza. And Tony's my cousin, so he's going to give me a good discount. All right, so again, graph, equation, still able to compare because we found the unit rate. $12 for one pizza, $15 for one pizza. The last thing, which I know is always students' favorite thing, is when you got a whole little word problem here. So we have here, it says the graph shows the amount of savings over time in Diana's account. So here's Diana's account. Again, I see it's proportional because it's starting at 0, 0, starting at the origin, and it's a straight line. Janet, meanwhile, puts $50 in her account each week, into her savings account. If they both begin with $0, so let's say they started they just opened these accounts, who is saving at the greater rate? So we have that right here. Janet, she's putting $50 in each week. So Janet equals $50 each week. I mean, that doesn't get much easier than that. It told us this is what she does, and we just write it down. So then we look at Diana's, and again, we have to find how much is she putting in each week. So the total savings here along the left-hand side. Again, the amount of money is going to depend on the amount of time. So the change in Y, I'm going to go here. That says 94. So she's putting $94 in. Change in X every 2 weeks. And when we do that division, we see that Diana is putting in $47 per week. So Diana's putting in $47 per week. Janet's putting in $50 per week. Janet is saving at the greater rate. Again, description, graph, still able to compare the two things even though they were represented differently. I hope everybody found this video helpful. Like and subscribe, and I'll try to keep as updated as I can. I hope everybody had a good Thanksgiving. I'm Mr. Oakes. Have a great one.